Okay, so now we got some more examples here, a little more complex. The limit of as x is approaching infinity of the cubed root of 6x plus 7 over 11x minus 3. So one of the rules of limits is you can kind of just take the cube root of the whole thing and kind of just worry about that at the end. So basically what we're just looking at is the limit as x is approaching infinity of this function. And we just solve it the way we have been, multiply by 1 over x over 1 over x, which is just 1. And you're going to cancel everything, and you're going to cancel that x, and you're going to get a 6 plus a 7 over x. And when you do that limit, you're just going to get 6. And then you do it on the bottom, and you just get 11 minus 3 over x. And once again, how we've been doing these limits, you get 11 on the bottom, you just get 11 minus 0. And then once you go into it at the end, you can just say, take the cube root of that whole thing. So you just get the cube root of 6 11s. And then for the next one, it's a little bit more complex now because we've got that square root of the x squared minus 7. So once again, we want to cancel, but 1 is different. The bottom is different from the top. So what we're going to do is do the square root of 1 over x squared over 1 over x. Now this isn't a problem because the square root of 1 over x squared equals 1 over x, so we still are only multiplying the entire equation by 1. But this makes it easier to work with, because then on the next part we have the limit as x is approaching infinity of the square root of 1 minus 7 over x squared, because that 1 over x squared can go into that square root, over 8 plus 3 over x. And then this is just going to all equal the same thing. We're going to take the limits of those and get 1 minus 7 over x squared and 8 plus 3 over x, and the limits of those are just going to be 1 over 8, and that's your answer, 1/8.
Alright, now we're going to be working with some limits as they approach negative infinity. The first problem is the limit as y approaches negative infinity of 5 plus y over the square root of 3 plus y squared. See, the different thing you have to do when your limit is approaching negative infinity is when you're multiplying your original equation by the thing to simplify it out, you're going to change it and make it negative because the limit is approaching negative infinity. So what you're going to do is multiply it by 1 over negative y divided by the square root of 1 over negative y squared. And then that's going to get you negative 5y minus 1 over the square root of 3 over y squared plus 1. And then when you do those limits, you're just going to get negative 1 over 1, and then that just equals out to negative 1. And then for this next problem, you have the limit as t approaches negative infinity of 2t plus 3 over the square root of 3t squared minus 5t. And then you're going to do the same thing you did for the other problem. It's just multiplied by 1 divided by negative t over the square root of 1 divided by t squared. And that's going to get you negative 2t minus 3 over t squared divided by the square root of 3 minus 5t. And then when you do all those limits out, you're just going to get negative 2 over the square root of 3. And then your final answer is going to be negative 2 square root of 3 divided by 3.
Okay, so once again, we're going to have some more complex examples. Once again, x is approaching negative infinity, and we have the square root of 5x to the fourth plus x cubed over 3x squared minus 7. So once again, you can just manipulate it so that you have the square root of 1 over negative x to the fourth over 1 over x squared. Once again, if you just take the square root of 1 over x to the fourth, it's going to equal x squared. But the interesting thing also is if you just take the negative x squared, it's just going to be a positive x squared, so you kind of just don't have to worry about that either. It's just going to end up equaling the square root of 5 plus 1 over x over 3 minus 7 over x squared. And then you just take the limits of those. Once again, limit of 5 is 5 plus limit of 1 over x is infinity, or is 0, it's just approaching 0. And then once again, the limit of 3 is just 3. And then 7 over x squared, that's once again going to be 0. So you just get square root of 5 over 3. The next one is a little bit different because you're going to take the limit as x is approaching infinity. You're going to have 5 minus x to the sixth and 6x to the fourth plus x plus 7. And this is just indicating that you have to cancel the x's on the bottom. If you have an x on the bottom that's not in the denominator of the denominator, then you're going to end up getting an infinity on the bottom, and we can't work with that. So the whole idea is we're going to have 1 over x to the 4th so that you cancel out the 6x to the 4th. And once you do that, you get the limit of x is approaching infinity over limit as x is approaching infinity of 5 over x to the 4th minus x squared all over 6 plus 1 over x to the 3rd plus 7 over x to the 4th. Once again, simple limits, you just get negative infinity in the end.
Alright, this time for the limits, it's not approaching infinity or negative infinity anymore, it's approaching 0. So the problem is the limit as delta x approaches 0 of square root of x plus delta x minus the square root of x all over delta x. And what you're going to want to do is multiply the conjugate of the numerator, and then that's going to be the square root of x plus delta x plus the square root of x over square root of x plus delta x plus the square root of x. And that's gonna work out really nice when you multiply it through, because the x minuses from the x and those just cancel out, and then the delta x from the numerator cancels out with the denominator, and then that's gonna get you 1 over the square root of x plus delta x plus the square root of x, and then when you plug in 0, your final answer is just going to be 1 over 2 square root of x.
Okay, so the issue here is we've just got the limit of a function as x is approaching a constant of 3. So normally to find this out, you would just plug in x for all the, or 3 for all the x values, and you would get what this function is approaching. But the problem with this is when you do that, you get 0 over 0. So we can't have that. That doesn't exist. So the whole idea of this one is you want to just manipulate the top and the bottom of this function so you can get some canceling maybe, and then plug in 3 at the end and possibly get a real number. So first off, we just go to the denominator. We see x squared times x minus 3 plus 1 times x minus 3. So with that one, you can automatically just factor out that x minus 3, and you get x squared plus 1 times x minus 3 on the denominator. So that's something you can work with. Maybe we can do some canceling at the top. So now what we got to figure out is how are we going to cancel one of those with the top. That top equation is x to the 4th minus 7x squared minus x minus 15. So first you just kind of trial and error, or you just see if the x minus 3 will go into that. So you do this long division type equation with the 3 and the coefficient of the x to the 4th, the coefficient of x to the 3rd, which is just 0, the coefficient of the x squared minus 7, coefficient of the x minus 1, and the coefficient of just the constant, that's just negative 15. So you do that all out, and you get a new equation. You get the 1, the 3, the 2, the 5, and the 0. So it goes in evenly because we have that 0 on the end. So that's going to all come out to x cubed plus 3x squared plus 2x plus 5. So basically what we just did there was prove that x minus 3 times that whole equation equals the x to the 4th minus 7x squared minus x minus 15. And that's good because all we have to do now is we have an x minus 3 on the top and an x minus 3 on the bottom. Those two cancel. So now we just have the x cubed plus 3x squared plus 2x plus 5 all over the x squared plus 1. And we just plug in 3 for all of those values, and we go through, and it's just going to be 65 tenths, which is just 13 halves or 6.5.